Okay, so third time's a charm because each time I keep going to 10 minutes trying to explain this project. Anyway, so all the deletes in asset and central time are now private instead of public. So there's that, and they're accessed via their friend or their attorneys in the engine. Camera manager now deletes all the cameras it creates when it's employed, so it cleans up its memory. Uh, just open up this real quick. The scene manager is now cleaned up in the very end. It calls the scene attorney scene manager kill delete, which just calls the delete on the scene manager. Scene change is now separated and used as a singular, or it uses set commands now. Where the hell I put it? It uses set commands, so here's a singular scene change command, and then it just uses a set for the whole scene. Da 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 da. Alarmable, I took out all the delicious looking switch statements and just put the weird jackway that was discussed in class way long ago. Collidable system visualizer is now engine level because it's a debug tool, so it calls its own process there. And then it has connection to creating its own broker. The broker now also acts as a pool, so the add commands is sort of like the whole factory. Create bullet fun stuff, but instead creates commands or uses the new setter functions to change the internals of the commands, and the major changes, instead of deleting it, sends it to storage, and then when the visual broker is destroyed, it clears out the storage list. The collidable group you said doesn't work, but it does. Here, where did I put you? Jeez, I have too many things. On the, pretty sure I explained this before, this collision manager destructor, these commands themselves call the delete, um, call the delete commands, and the delete commands are created every time a collidable group is created, meaning once you cycle through all of them, it calls their internal deletes and terminates to clean up all that fun stuff, and then the commands delete themselves, and then for clearing it, the deregister of the collidable takes it out of the actual group. I don't know if that's correct, but that's what I have. Efficiency, I haven't touched base yet because I'm still confused on what exactly is inefficient about it. I might have just realized it speaking on this, but anyway, past that, all the math stuff I now have put into its proper place. I removed the double test, and then for sprite, I did what you asked and took out drawable, and now the user is in charge of calling drawable and all that fun stuff. So everything connects properly. Um, and then, yeah, for the project I had, I guess I could show you an example. So the reticle now calls submit 2D draw registration, which is a separate drawable registration function specifically for the sprites. And then in the actual draw cycle, they have to call the sprite to call sprite draw, which then registers that sprite, or not registers, but renders that sprite, so to speak. And just to show that it works, I'll play it. But while this is loading and stuff in the background, um, I was originally going for a more simple AI project, but you said that wasn't as ambitious enough, so I delved deep into what Brandon suggested, and the path I would take is producing a data set, or at least the variables needed to produce a data set. I'd have to create a separate system within the engine to register all of the world activity into that data set to populate, I guess, the data set itself. So things like player position, once we have height maps and terrains, I guess position on the height map and such, and all that fun stuff. But essentially, compile all those data sets to be sent into a .arff file, which essentially takes all the variables and then applies either a 1 or 0 to it based on the data set you provided, and then outputs the info not the info, but the results into a separate category, either one that is needed or more desirable or not, because it's machine learning. And essentially, I'd be sending that all towards a program called Weka, which is produced in New Zealand, which they essentially use that for what is the term? Supplemented machine learning, where you provide different cases of or different data sets, and with each data set you define whether it's a desirable result or an undesirable result, and it outputs it into a JavaScript file, I believe, if I read that correctly. Essentially, I'd be using all that data to send into Weka to produce that Java file, and then convert that back into something readable by, I'd have to create another system on top of that to convert that into C++, which then needs to be fed back into the AI so that it could, quote unquote, learn what to do with a player to kill them or for more survivability or something like that. And realistically, I don't think I could pursue that specific route, only because life obligations are stacking up and I gotta make sure I could actually produce something for an end project. So I'm thinking I might not go as ambitious with the whole machine learning thing, and instead propose something along the lines of implement a state machine. So back on the lower end of the spectrum of implement a state machine and combining it with a few other systems like a very simple particle system, maybe even using the Erklang for sound. I don't know. I have to reevaluate because the time management thing is going to be off the charts for this quarter compared to last with all the obligations I have. I'm sorry. But yeah. Oof.